Welcome YouTubers to another episode in my Grammar Hero series. In this video I'm going to discuss fractions. More specifically, I'm going to discuss fractions as they pertain to the math computation section of the TABE test. So first I want to start by saying for the TABE you'll need to know how to reduce, add, subtract, multiply, and divide fractions. And in addition to doing all those operations with fractions, you'll also have to be able to work with mixed numbers. In this lesson, I'm going to discuss each of those topics at length, so by the end of it, you should feel fairly confident that you can deal with any fractions that you may see on the TABE test. So the first concept I want to touch on is reducing fractions. To reduce a fraction, you find a number that divides evenly into the numerator, which is the top number in the fraction, as well as the denominator, which is the bottom number in the fraction. Okay, so if I were to give you the fraction 5/8, you can see 5 would be the numerator and 8 would be the denominator. Through this video, I'm going to refer to those terms, so I just wanted to introduce those early on. Okay, so let's take a look at an example of reducing a fraction. Let's say I gave you 12/16 and asked you to reduce it. You would say to yourself, well, 2 goes into 12 and 2 goes into 16, so let's divide 12 divided by 2 and 16 also by 2. 12 divided by 2, of course, is 6, whereas 16 divided by 2 is 8. You can look at this and say, well, I think 2 can still go into 6 and 8, so let's reduce it a little more. 6 divided by 2, 8 divided by 2. 6 divided by 2, of course, is 3, whereas 8 divided by 2 is 4. This 3/4 is in reduced form because there's no number by which we can divide top and bottom to reduce this fraction. Okay, similarly, you could have looked at 12/16 and said, I see that 4 goes into 12 and 16. So you could have done 12 divided by 4 as well as 16 divided by 4. That, of course, would get you 3/4. Again, the goal in reducing fractions is to find a number that you can divide in the numerator and denominator to make the fraction such that you can reduce it. You can't reduce it any further. So let's just do one more example. Again, 5/10. You might be saying to yourself, well, I know 5 can go into 5 and 5 can go into 10, so let's reduce this by a factor of 5. So 5 divided by 5 as well as 10 divided by 5. This becomes 1/5 goes into 10 twice. So as we can see, we're in reduced form. Again, I'm not going to do too many examples of reducing fractions. Many of you are probably pretty comfortable doing this, okay? Just one thing I want to note, as you reduce fractions, all the different reductions are going to be equivalent. So 12/16 is equivalent to 6/8, which is equivalent to 3/4. That's because fractions are division problems in essence, and it turns out all of these, when you divide them out, are equivalent to 0.75 or 75%. Okay, let's talk about multiplying fractions. Multiplying fractions is a pretty straightforward process. When you multiply fractions, you simply multiply the numerators together, multiply the denominators together, and then reduce if possible. So let's take a look at an example here. Let's do 5/6 times 2/3. Again, multiply fractions. You do 5 times 2, 6 times 3, so that looks like this. 5 times 2 is 10. 6 times 3 is 18. Now, we've done the multiplication of the fractions. Now we just need to reduce it. So let's go ahead and divide 10 by 2 and 18 by 2. 10 divided by 2 is 5. 18 divided by 2 is 9. So now we have the fraction in reduced form. Let's just do another example, although at this point you're probably pretty comfortable with this concept. Let's do 1 over 10 times, let's do 1/2. Again, we're just multiplying numerators by each other, denominators by each other, and reducing. So this becomes 1 times 1 over 10 times 2. 1 times 1, of course, is 1. 10 times 2, of course, is 20. Okay? So we can see right there that we are finished. We cannot reduce this any further. Dividing fractions, it turns out, is just as straightforward as multiplying fractions. That said, there's one additional step you need to be aware of, and I like to refer to that additional step as keep, change, flip. So multiplying fractions or dividing fractions is the same as multiplying fractions. You just have to set up your problem. Okay? So what keep, change, flip refers to is you keep the first fraction the same, you change the sign from division to multiplication, and then you flip the second fraction and multiply accordingly. So if I were to give you this problem, 5/9 divided by 2/3, we would first look at keep, change, flip. So keep this first fraction the same, that is, keep 5/9 the same, change the sign from division to multiplication, and flip this second fraction to be 3/2. Now we have a multiplication problem, which we just dealt with in the previous example. Again, we're going to multiply numerators together and denominators together, so that's going to give us 5 times 3, 9 times 2. It's going to give you 15 over 18. Again, we can try to reduce this by a factor of 3. So this becomes 15 divided by 3, 18 divided by 3. 15 divided by 3, of course, is 5. 18 divided by 3, of course, is 6. Okay? Now it's in reduced form and we're done. Again, keep, change, flip is what you do to turn division problems into multiplication problems, which we already know how to do fairly easily. Okay? So let's do another one. Let's do 1/2 divided by 3/4. Again, you can also be given a division problem like this. 1/2 divided by 3/4. Same thing applies. Keep. So 1/2 stays the same. We're keeping that the same. Change the sign from division to multiplication and flip the second fraction. So instead of being 3/4, it's going to be 4/3. Okay, multiply accordingly. Again, just multiply numerators together and the denominators together. 1 times 4, of course, is 4. 2 times 3, of course, is 6. Let's reduce this by a factor of 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Again, we're done. Dividing fractions is the same as multiplying fractions. You just use KCF, or keep, change, flip, to turn the division problem into a multiplication problem. So let's talk about what happens when you multiply and divide fractions by whole numbers. To multiply and divide fractions by whole numbers, you simply turn the whole number into a fraction by placing it over 1. So for example, the whole number 5 is the same as 5/1, and 100 is the same as 100/1. If you were to put this in a calculator, if you were to put 100/1 in a calculator, it would just be 100. Again, anything multiply or divided by itself is itself. So using this, we can actually work with whole numbers and fractions. So let's take a look at an example. 3 over 5 times 4. Again, at first glance, this may be difficult because we're saying, well, that's a whole number. What can we do? So let's just use this concept I introduced to make this an easier problem. 3 over 5 times, instead of 4, let's make it 4 over 1. Now it's a multiplication problem. Again, numerators, we're going to multiply together, and denominators, we're going to multiply together. This becomes 3 times 4 over 5 times 1. This becomes 12 over 5. Okay, and there's nothing by which we can reduce this fraction, so it's in reduced form. Let's do a division problem. Let's do 1/3 divided by 6. Again, at first glance, we're probably saying, what can we do? Put 6 over 1 and move forward. So 1/3 divided by 6 over 1. Using what we just learned, we know we can use keep, change, flip to turn this into a multiplication problem. So keep the first one, 1/3. Change the sign from division to multiplication. Flip the second fraction. So this becomes 1 over 6. Multiply across. This becomes 1 times 1. 3 times 6. 1 times 1 is 1. 3 times 6 is 18. Can't reduce this by anything, so it's in reduced form. So again, multiplying and dividing fractions by whole numbers, pretty straightforward. Adding and subtracting fractions with the same denominators is simple as well. You simply just, when you're adding and subtracting fractions which have the same denominators, you're simply just subtracting the numerators, putting them over the denominator, and reducing. So, for example, 9 divided by 10 minus 3 over 10. Again, we're going to keep the denominator the same, but we're going to subtract the numerator. So 9 minus 3 over 10. 9 minus 3 is 6. Keep the denominator the same. Reduce, so we can reduce this by a factor of 2. 6 divided by 2 is going to be 3. 10 divided by 2 is 5. It's in reduced form, so we're done. Again, when the denominators are the same, you keep the denominator throughout the problem, and then you just subtract the numerators. One more example. And at this point, you're probably saying to yourself, this stuff's so easy. You know, why was I so concerned about it? Well, as you'll see in just a few minutes, we're going to have to work with all these concepts at once, which is where people get lost. So just bear with me, we're getting to more difficult concepts. So again, just add the numerators, 2 plus 1, keep the denominator the same. 2 plus 1 is 3, keep the denominator the same, 3/8. We cannot reduce this, so we are done. Okay. Adding and subtracting fractions with different denominators. This is slightly more difficult. It requires one more step than when the denominators are the same. We need to find common multiples of the denominator to get the denominator over the same, to make the denominators the same, and then we follow the rules I just introduced. So let's take a look at an example. 3 over 4 minus 1/2. Since the denominators are different in this case, we can't just go ahead and subtract 3 by 1 and be done. Instead, we have to find a number we can put both of these over to make the denominators the same. So let's look at multiples of 4. Multiples of 4 are 4, 8, 12, 16, 20, and so on. Multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. As you can see, we have a common multiple of 4 here. Okay? So in other words, we can put both of these fractions over 4 and then use our addition and subtraction rules with the same denominator to finish this problem. So let's take this in isolation. To put 3 over 4, we don't have to do anything. It's already set up for us, okay? To put 1/2 over 4, we need to find a number by which we can multiply this 2 to make it 4. We know 2 times 2 is 4. What we do to the bottom of the fraction, we do to the top of the fraction. So this becomes 2 times 2 is 4. 1 times 2 is 2. Okay? So I basically took this second fraction, put it over 4, and now we could just simply subtract the numerators and be done. This becomes 3 minus 2 over 4, or just 1 over 4. Okay? Let's do another example, since this concept's a little bit more difficult than anything I've introduced thus far. Let's do 2/5 plus 1/4. Okay? As you can see, the denominators are different, so we can't just add the numerators. Instead, we have to find a common multiple over which we can put both of these fractions. So let's go ahead and write out the multiples of 5. It's going to be 5, 10, 15, 20, 25, and so on. Let's write out the multiples of 4. It's going to be 4, 8, 12, 16, 20, 24, and so on. Again, is there a common multiple between these two? There's 20 here and 20 here. So in other words, we're going to rewrite these fractions so they're both over 20, and then use our rules to do the simple addition of the fractions. So now we have to ask ourselves, what do we multiply 5 by to get 20? The answer, of course, is 4. What we do to the bottom, we do to the top. Okay, so when we rewrite this, this becomes 4 times 2, 8. 4 times 5, 20. Okay, now we're asking ourselves, what can we multiply 4 by to get 20? 4 times 5 is 20. What we do to the bottom, we do to the top. Of course, 5 times 1 is just going to be 5. Now we do a simple multiplication or addition of fraction problem. Just add the numerators. 8 plus 5. Leave the denominator the same. 8 plus 5, 8, 9, 10, 11, 12, 13 over 20. And since 13 is a prime number, we can't reduce this any further. Okay? So now let's talk about improper fractions, and more specifically how we convert them to mixed numbers. Just to give you a definition, an improper fraction is a fraction in which the numerator is greater than the denominator. So in this case, we can see 7 is the numerator, 2 is the denominator. 7 is bigger than 2, so this is an improper fraction, and we can convert it to a mixed number if we wanted to. To do that, you perform long division. So the way I read this fraction is 7 divided by 2, which looks like this. 7 divided by 2. It's a long division problem. Now we say to ourselves, how many times does 2 go into 7 without going over? 2 times 3 is 6. 2 times 4 is 8. So we're going to go with 2 times 3. Subtract 6 from 7. That gives us 1. Does 2 go into 1? It does not. So that is our remainder. So this is 3 remainder 1. And when we're working with remainders and fractions, we actually take this remainder and put it over the divisor. So this would actually be 3 remainder 1 over 2, or 3.5. Okay? Let's try another one just to make sure we got it. Again, numerator is bigger than the denominator, so this is a mixed number, or an improper fraction, which we can make a mixed number. To do that, we use long division. I read this as 13 divided by 3. How many times does 3 go into 13 without going over? 3 times 4 is 12. Let's subtract that out. Again, 3 times 13 minus 12 is 1. Does 3 go into 1? It doesn't, so this is our remainder. So this is 4 remainder 1. When we're converting to mixed numbers, we take this remainder, put it over the divisor, so this becomes 4 with a remainder of 1 over 3. Let's try just one more to make sure we got it. Okay, so let's do 12 over 7. Again, numerator is bigger than the denominator, so we know we're working with an improper fraction. I read this as 12 divided by 7. How many times does 7 go into 12 without going over? 7 times 2 is 14, which is greater than 12, so we're just going to use 1. 12 minus 7, 7, 8, 9, 10, 11, 12, 4. Does 7 go into 4? It doesn't, so we know the remainder is going to be 4. And to make this a fraction, we take this remainder, put it over the divisor, so this becomes 1 and 4 sevenths. Okay? So let's talk about the reverse. That is, let's talk about how we go from mixed numbers to improper fractions in case we need to do that. So we got 5.5 as our mixed number. To go to a fraction, you follow this algorithm. You do whole number times denominator plus numerator all over denominator. Again, whole number times denominator plus numerator all over the denominator. So again, everything's going to be over the denominator. Let's go ahead and put that down there. So whole number times denominator, that's 5 times 2, plus numerator, that's 1. 5 times 2 is 10, plus 1 is 11, so this is 11 over 2. Again, let's convert this one now, 6 2/3. Again, algorithm. Whole number times denominator plus numerator all over the denominator. So let's go ahead and throw down the denominator since we know that's going to be the same. Again, whole number times denominator, 6 times 3, plus numerator. 6 times 3 is 18, plus 2 is 20. So this is 20 over 3. Let's try one more. Let's convert 5.25 to an improper fraction. So again, algorithm. Whole number times denominator plus numerator all over denominator. So let's go ahead and put our denominator down. Whole number times denominator, that's 5 times 4, plus numerator, that's 1. 5 times 4 is 20, plus 1 is 21 over 4. Okay? So the final part in this lesson is going to be adding, subtracting, multiplying, dividing mixed numbers, fractions, and whole numbers. This is going to test all of the skills you've learned so far. Okay? And you'll see that we're going to have to, in some cases, go from whole numbers to mixed numbers and improper fractions to mixed numbers and vice versa. So let's take a look at this first example. We have 2 over 5 times 1 and 1/6. Remember when we multiplied fractions? In the second case in this example, we simply multiplied numerators and denominators together. Well, I can't do that because we have a mixed number here. Instead, I have to convert this mixed number to a fraction, and then I can follow the rules for multiplying fractions. So let's do that off to the side. Again, the algorithm. Whole number times denominator plus numerator all over denominator. So that's going to be 6. 1 times 6 plus 1. 1 times 6 is just 6, plus 1 is 7 over 6. This becomes now 2 over 5 times 7 over 6. Now we just multiply straight across, as I taught you just a few minutes ago. So this becomes 2 times 7 over 5 times 6. 2 times 7 is 14. 5 times 6 is 30. Now we can reduce this if we wanted to. We can divide top and bottom by 2. 14 divided by 2 is 7. 30 divided by 2 is 15. Can't reduce this, it's in reduced form. So this combined your knowledge of converting from a mixed number to a fraction, improper fraction, and multiplication of fractions. Okay? Let's do another example. Let's see. And I'm going to use the same numbers throughout these problems just so we get comfortable with the idea. So let's do 2/5 divided by 1 1/6. So again, we have, sorry about that. Again, we have a division problem. We know how to deal with that. But we have this mixed number here. Again, we got to convert this mixed number to a improper fraction before we can do anything. Again, whole number times denominator plus numerator all over denominator. So 1 times 6 plus 1, which becomes 7/6. Let's rewrite this. 2/5 divided by 7/6. Now, again, case 2 or 3 was dividing fractions. It had one additional step, that is keep, change, flip. Keep the first fraction the same, that is 2/5 is going to be the same. Change the sign from division to multiplication. Flip the second fraction, so this becomes 6/7. Now it's a multiplication problem, so we know we're multiplying straight across. This becomes 2 times 6/7 times 5. That is 12/35, which we cannot reduce. It's in reduced form. Okay? Okay, let's try another variation of this problem. 2/5 plus 1 1/6. And again, now this is an addition problem with a mixed number. Let's first convert this to a fraction, which we did up here. So let's just rewrite this as 2/5 plus 7/6. Okay. Now it's a simple addition problem of fractions. Again, we need to find a common factor over which we can put both of these fractions. So the factors of 5 are 5, 10, 15, 20, 25, 30, 35. Factors of 6 are 6, 12, 18, 24, 30, 36, and so on. Do we have a common factor? We do. 30 and 30. So let's put both of these over 30 and then work it out accordingly. 5 goes into 30 6 times, so we'll multiply this by 6 to make it, or 6 to make it 30. We do the bottom, we do the top. To get 6 to 30, we multiply it by 5, but we do the bottom, we do the top. So this becomes 30. 6 times 2 is 12, plus 30. 7 times 5 is 35. Now it's a simple addition problem with the denominators the same. 30 is going to be the denominator. We're not going to change that. 35 plus 12. Let's work that out to the side here. 5 plus 2 is 7. 4 plus or 3 plus 1 is going to be 4. So this becomes 47/30. It's an improper fraction. You can convert this to a mixed number if you wanted to, but we're just going to leave it like that for this example. And our final example of the lesson, 1/5 plus 2. Okay, so first, as I mentioned earlier in this lesson, you want to convert this 2 to a fraction. To do that, you put it over 1 like that. So this becomes 1/5 plus 2 over 1. Now this is an addition problem. We need to get the denominators the same. So let's find some least common multiples, or common multiples. Multiples of 5, 10, 15, 20, 25, and so on. Multiples of 1, 2, 3, 4, 5, 6, 7, 8, and so on. Do we have a common multiple? 5. Okay. So we're going to leave this one alone since we're going to put everything over 5. To get this over 5, I'm going to multiply 1 times 5 and 2 times 5. Because what you do at the bottom, you do the top. 1 times 5 is 5. 2 times 5 is 10. Denominators are the same, so we can simply add. This becomes 11 over 5. If we wanted to convert this to a mixed number, that'd be fairly easy. We do so with long division. I read this again as 11 divided by 5. 5 goes into 11 twice without going over. 5 times 2 is 10, of course. Subtract, we're left with 1. Does 5 go into 1? It doesn't, so this is 2 remainder 1. When we're dealing with fractions, we put the remainder over the divisor. So this becomes 2 and 1/5, which is the same as 11 over 5. And we are done. So again, if you can keep all those rules straight, you should do fairly well when it comes to dealing with fractions on the math computation of the section of the TABE. Again, watch this video again if you need to. On my website, which I'm in the process of creating, I'll have actually a practice quiz. And I recommend that you get at least 100% on that practice quiz before you move on to the next lesson. Okay, so feel free to leave feedback in the comment section below. Plus, press the like button if you found this video helpful. But on that note, I'll go ahead and cut you guys loose. Konnichiwa.